Hi and welcome to my calculus clinic. This is Dr. Gadanakla. Today we will be looking at using double angle identities to solve integrals. And as you might have already come across double angle identities, these represent themselves in the form of sine 2x is 2 sine x cos x. And as you will notice here, this is a single angle and this is a single angle, but this is twice as much, twice the angle. So if x over here is 3x, then this will be 6x, and this will be 3x again. If it's, for example, 2x and 2x, then obviously it will be sine 4x. It's double, you double the angle. You do not double the 2, you leave the 2 alone, you double the angle, and that's why we call them double angle identities. Same with the cos 2x is equal to cos squared x, and again, as you will notice, the angles are single, minus sine squared x, or it's equal to 2 cos squared x minus 1, and again, angles are single, or minus or 1 minus 2 sine squared x. Okay, same with the tan. You will have tan 2x, which is 2 tan x, and 1 minus over 1 minus tan squared x. Again, you will see that these are single angles on this side and double angles on this side. So if we are to say this is 2 tan 2x, then obviously I will be looking at tan 4x. And we will apply this to a few questions now, and we will see how it works. Let's take a look on the first question. And I'm integrating sine 3x cos 3x dx. This is what I'm integrating. So I need to go back here and think which identity am I going to go for? Do I go for the top identity sine 2x, cos 2x, or tan 2x? Clearly, it's not going to be tan 2x. It's far away from tan. Cos, not really. Okay, so this means I'm left with the sine 2x. I'm left with this one here. It looks good to me. It should work. Now, what is missing? This 2 is missing. I need to multiply my question by 2 over 2. 2 over 2 is 1. So you've multiplied it by 1, and anything multiplied by 1 in mathematics stays the same, which means that I'll end up with a half, which is this 2 here, and the integration of 2 sine 3x cos 3x dx. Let's go back and see, does this look familiar? 2 sine 3x cos 3x. Yes. Sine 2x should work. So you double the 3. So this is the same as half. And then you're integrating sine double the 3, which is 6x dx. So you're integrating sine 6x dx. Now it's a lot easier to integrate. So let's start integrating. As we already know, this is the positive y-axis, so sine. This is the positive x-axis, so it's cosine. On the other side is the negative, so it's going to be minus cos, and over here will be minus sine, and this is the negative y-axis. You differentiate this way, so you differentiate sine to get cos, cos to get minus sine, and so on, or integrate this way. When you integrate sine, you get minus cos, and so on. And we are integrating. So we're integrating sine kx. So when you integrate sine, you get minus cos. So you're going to go 1 over k minus cos kx. So let's integrate. Leave the half alone. And this will integrate into 1 over 6. 1 over k. When you integrate, you go 1 over k. And then minus cos kx. And k is 6 plus c. Okay, when you integrate sine kx, you get minus 1 over k cos kx. And then you tidy it up, so you end up with minus 1 over 2 times 6 is 12 cos 6x plus c. And leave it there. Let's take a look at something slightly different. And I think we're on question 2 now, and I'm integrating 6 cos squared 3x dx. Now let's recap some of the formula up there instead of keep scrolling up and down. And I know that cos 2x is equal to 2 cos squared x minus 1. This is one of the three identities for cos 2x. So cos 2x is 2 cos squared x minus 1. Can I manipulate this a little bit? I sure can. So I can go cos 2x, move the 1 to the side or add 1 to both sides. So plus 1, right? And that should be equal to 2 cos x, right? 2 cos squared x. So I'm going to divide both sides by 2. Therefore, divide both sides by 2. So cos squared x will be cos 2x plus 1 divided by 2. Okay, now we need to be careful. This is double angle. This is single angle. Okay, right? So in this case, I have cos squared 3x. So let's get a different color. Let's go blue. And let's write this down. So equals, the 6 will kick 6 out of the integration. It's a constant. We don't integrate constants. We only integrate x. So I've got cos squared 3x. So instead of cos squared 3x, right, I'm going to have cos double the 3, so 6x. So I'm doubling. This was x. This is 2x, right? So I'm doubling it. Okay, which will give me 6x plus 1 divided by 2 dx. So the cos 3x becomes cos 6x plus 1 divided by 2. And the reason why I doubled, because if you look at this identity here, after manipulating it, it becomes double the angle. So I have doubled the value of x, which in this case is 3x. Right, let's finish it off. 6 divided by 2 is 3, so I can put a 3 there, and then I'm integrating cos 6x plus 1 dx. Looks simple enough to me now. Let's then integrate. So 3. Now, when you integrate cos, let's draw the diagram again. Sine, cos, minus cos, and we are integrating, so we're going this way, and I'm integrating cos. So when you integrate cos, you get sine, but you're integrating cos 6x. So it's going to be 1 over k sine kx. So it's going to be 1 over 6 sine 6x, k is 6, plus, and we can have a pair of brackets here. 1 integrates into x plus c. And this is actually is x to the power of 0. Anything raised to the power of 0 is 1. So the 1 is actually x to the 0. When we integrate, we increase the power of x, divide by the new power. So we're going to increase the 0 to 1, to x to the power of 1, and then divide by the new power. Okay, let's tidy it up. And we can choose to leave it there, or we can choose to simplify it further. So let's multiply out the brackets. 3 times 1 over 6 is a half sine 6x plus 3x plus c, and we can leave it there. And what I did here is I've multiplied 3 divided by 6 is a half, and then multiplied the 3 by the x to give you 3x plus c. Let's take a look at a different example. Okay, we're on question 3 now, and we are integrating this time, and we are integrating cos x minus sin x, and then cos x plus sin x dx. So I'm integrating a couple of brackets. The first thing you would want to do is make it simple, simplify it. And you can do that by multiplying the brackets out. And you can use FOIL, you can use Freddy Frog, whatever method you've been taught at school. Or instead of multiplying these out, you might already notice that this is what we call in mathematics the difference between two squares. Cos x minus sin x and cos x plus sin x is the difference between two squares because the middle terms will cancel. Feel free to expand it in your own time, but what you should get is you should get cos squared x minus sine squared x, difference between two squares, dx. Okay, let's go back to the identities. I've got cos squared minus sine squared. Is this a straightforward one? Is it one of those that identities that I can use? And yeah, it's here. So this is it. This in fact is equal to cos 2x. So I can use this identity. So I can go, oops, back here, oops. I can go back. Oops, here, right? And then I can say that this is equal to the integration of cos 2x dx. Integrating this should be very straightforward, all right? Let's try sine cos minus cos. We are integrating, so we're going this way and we're integrating cos. So cos should integrate into sine, and I'm integrating cos kx. So let's go 1 over k. K is 2, so 1 over k, so 1 over 2, right? Sine 2x plus c. K is 2. Okay, right? Let's take a look at something slightly different.